David Smith here with one more Flipped Classroom math video. 3 tips before we start. Remember, you can pause the video at any time to catch up with your notes. You can also turn on the caption down below and watch my words go by on your screen. Lastly, if you feel like you can do this, you can speed up the playback and get through the video a little bit faster. Today's lesson revolves around finding constants. So up until now, we've just had to say plus c because when we take the integral, we just don't know what that constant was. So now we're going to lock that down. Now you need a little bit of more information from what you've been given. So we'll cross that bridge when we get there. But let's start here. Okay, so if f prime of x, so if the derivative of f of x is 2x minus 3 to the third power, find f of x. So this is just another way of saying take the integral of 2x minus 3 to the third power. Remember, integration is anti-derivation. Okay, so go ahead, and this is our rule for that. I reproduced that up here so we could use it nice and quick. Go ahead and take the integral of that so we can find out what f of x equals. Okay, so I did my steps. Here's my plug-in step according to our rule, and then I went ahead and simplified us on down. So now we know that f of x is 1/8 2x minus 3 to the fourth power plus c. So that's an indefinite integration. However, we can specify that we want to make this definite. And here's how we do that. Okay, so here's one type of initial information that you're going to need to get. It's called a boundary condition. All right, so here's how we do that. We have this thing called a boundary condition. We know, or we're being given, that when you put 1/2 into the function for x, like in that spot, crunch your numbers, you're going to get 4 out. F of x is going to be 4. So now we can do a plug-in step, and c will be our only variable, and we can solve for that. So watch this. If f of x is 4, that means this is 4. So I'm going to write 4 equals 1/8 times 2 times 1/2. There's my 2x minus 3 to the fourth power plus c. So I've got just a bunch of numbers and a c. So I can get all the numbers to one side, and I'll know what c is. So go ahead, pause the video, finish all this algebra out. All right, here you go. So the first thing I did is I just combined all this stuff together in the parentheses. So we wind up with -2. Brought my plus c down. Of course, brought my 1/8 down and my fourth power. Did my fourth power. That gives me positive 16 times 1/8 plus c. That ends up being 2. There's 2 plus c equals 4. Subtract the 2 from both sides. I have c equals 2. Cool. So then we just come right back to our function. F of x is 1/8 times 2x minus 3 to the fourth power plus 2. So that's a definite integration because we were given this boundary condition. This tells us or allows us to be able to find our c. So that's a definite integration because we were given this boundary condition. This tells us or allows us to be able to find our c. Okay, here's a problem that may at first blush seem a little complex. It's actually pretty doable. So let's walk you through that. I hope you come up with the same conclusion when we're done. So we have some curve, y equals g of x. So here's a function that's going to determine the y value in our curve. Now we know that this curve passes through the point 2 and then 5 times e to the 8th power. Now this is kind of like we're going to leave the e there. You could put this in your calculator and get a big, hairy, long number. But let's just leave the e in there. I think that's going to become convenient for us. Okay, so we have this function, g of x. We know it passes through this point. The gradient of the curve is g prime of x equals 8e to the 4x. Now, when you hear about a gradient function, you should remember that the gradient function is the derivative of the original function. They've given you an additional one more clue. They've called this one g prime, and they're calling that one g. So this is the original function. That defines the curve, passes through this point. The gradient function, g prime, is this, and that tells you the gradient of the tangent line to the curve at any point along the way. So we're going to use all this information to answer this question. Find the equation of the curve, which is really, they're just saying, find g of x, is what they're prompting us to do. And you'll probably notice that we've got an e in our y value here, we've got an e in our function. So we're going to deal with taking some derivatives of functions with, or I'm sorry, taking some integrals of functions with e in them. So I reproduced our e function rule right over here, so we'll use that in just a minute. Okay, so first step, we need to take the integral of this function. So let's go ahead and write that down. Here we go, integral of 8e to the 4x. First step, let's get this 8 out of there. We're not quite in the right form that we need to be in to use our rule. So this is going to be 8 times the integral of e to the 4x. Now we can apply our rule. We have our a and our b. Our b is 0, so it's not going to come into play here. So what we're going to have is 8 times 1 over 4 times e to the 4x. The e does not change. We just get that 4 comes down below. So now I can finish this off and go, it's 2e to the 4x. And that is our g of x function. So woohoo, we have our function. Except this is plus c. And this is what we're going to be focusing on next. We need to find that c. So now we are given a point. So when you put 2 into the function, you get 5e to the 8th out of the function. So we can use this information and our function to find c. So go ahead, pause the video, see what you can do with that. At least just do our plug-in step and come back. Okay, check this out. So my y value, again, from over here, is 5e to the 8th. So that goes there. And then I plugged in my 2, that's my x value, for x in my function up here, which was 4 times x. So I got 4 times 2. So it's 2e to the 4 times 2 power, which is 2e to the 8th. So check this out. I have 5e to the 8th equals 2e to the 8th plus c. I can just subtract my 2e to the 8th from both sides, and I have c is 3e to the 8th. Now, don't get out your calculator and figure out what that number is. Let's just stay right here. So our function g of x is 2e to the 4x plus 3e to the 8th. That's a perfectly good number. We don't need to resolve e for this answer. Okay, as you notice from that last problem, we had kind of a real-life example, still pretty mathematical, but we did actually do it in the context of a function and a curve on a graph. So now we're going to do a problem that is analogous to a situation that could be in reality. So here's what we're dealing with. A fish population, it grows by dp dt, change in population as a function of time, and the function is 60 times the square root of time, where time is between 0 and 4 years. So 1 year, 2 years, 3 years, 4 years, okay? So here's our prompt. Actually, before we get to that, here's a condition that you're given. Initial population equals 140 fish. We're gonna have to interpret that in just a minute. Find the population after 4 years. Okay, so a couple things to see. First off, whenever you have initial, that means that your x value is 0. This is the starting point of our study. So time t equals 0 years before a year has passed by. So what this means is that point, that boundary condition, is the point 0, 140. So that's year 0, because we need an x value. They're really just telling us the population, which is a y value. Okay, so first critical thinking step, done. Second one, the population grows by this. So this function is the growth rate, okay? So it's telling you that the rate that the population grows by, not the population. So that's a little hard to see from the prompt. This isn't the prompt that's going to tell you the population, because you can check it out. Put in 0 for x, that's t equals 0, I'm sorry, for t, and you're going to get that's 0 times 60. So the population at time t equals 0 is not going to give you that 140. It's not the population function. It's the growth rate function. So we need the population function. Okay? So remember, now I'm going all the way back into our derivative section. If I have a growth rate population, that is the equation for the tangent line. Remember, the population is going to have some upward curve. The rate at any point is the tangent line at that time t. So at this time, the population is this. Here's the population curve, and here is the rate. So this is the derivative. So the rate, the slope of that tangent line is given by 60 square root of t. So this is the derivative of the population function, and we need to integrate this to get back to the original function. So that's what we're going to do. All right, so here we go. Integral of 60 times root t, which is the same as the integral of 60 times t to the 1/2 power. I applied my integration rule, my integration power rule, and here's my full-on plug-in step, nothing else done but plugging in the values where they go. Simplify this on down, and I like working with roots. You could have this be the 3/2 power for x, that's fine, that works as well. So my function, my population function, is 40 times root x to the third plus c. So now I need to find my c. And here is where this point is going to come in. Population is 140 when x is 0. What did I do wrong here? I shifted over to x. This has got to be a t. So population is 140 when t is 0. So let's find our c. That would be 140 equals 40 times the root of 0 plus c. So root 0 is 0 times 40. So, yeah, so that's right. This is going to wind up that c equals 140. So that is our c. So now we know our full-on function. Population as a function of time is going to equal 40 times t, the root of t to the third power plus 140. So there's our function. So now, to answer the question, what's the population after 4 years? We just have to plug in our 4 for that and solve. So go ahead and pause the video. You should be able to do that lickety-split. So when I plug that into my calculator, push all my buttons, I get 460 fish. So this problem is straightforward. I believe it is. The challenging part is seeing how you have to do this. So again, to summarize, fish population grows by, this is a rate function. So we know that this function is giving us the growth rate, which is the slope of the tangent line. So big critical thinking step means that you know that this is the derivative of some other function, which would be the population itself as a function of time. So we have to take the integral of this function to get the population growth function, which is what we did. We went ahead and did that. We have our c out here, so then we had to use this initial condition, time t equals 0, there is 140 fish present, and then plug that in to get our c value. So we have our full function, which is here, and then once we have that function, we can do a plug-in step with our 4 years down here to find out what the population is at the end of 4 years. So I think this is a good example of the kind of question that an IB test might throw at you.
Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also remember that you can watch the video again to remind yourself of what we did or deepen your understanding. If you enjoyed yourself, please click like or subscribe.